12 o'clock. Good afternoon to everybody. Today's webinar is about enabling you to extend the use of your engineering design data. And this webinar is going to be presented by Ryan Dugmore. And Ryan is the Consultancy Director of Theorem Solutions. And Theorem Solutions, they're an independent, privately owned organization, and they've provided software solutions to engineering and manufacturing industries for 30 years now. Ryan will tell you a lot more about Theorem Solutions, so I'll leave it at that for the moment, but I just wanted to introduce Ryan himself. Ryan has a first-class honours degree in computer-aided product design. He initially worked as a design engineer in automotive vacuum forming and injection moulding. And then at that point, he decided to join Theorem in 2010, joined them as a software test engineer, and he worked with CAD data and the ability to manipulate CAD data and all the things he's going to tell you about in a few moments. Over the past 12 years, Ryan's held a number of roles in Theorem's consultancy team. He's currently the Director of Consultancy, and he manages consultancy and support teams while still being an active consultant working with the data himself. Greatly looking forward to Ryan's talk. Could I ask, please, if you've got questions as we go through, please put them in the question area into the chat, please, and they'll be picked up at the end, and we'll go through them. Manuel Don Lopez is going to coordinate the questions at the end. Okay, the whole seminar is proposed to last for an hour, probably about 40 minutes of talking, and the remainder open for questions. So with no further ado, I'd like to hand over, please, to Ryan, your talk. Thank you.
Thank you, David, and thank you all for joining today. I think David's covered the title of the webinar there. I think principally we understand the cost of design and management of creating CAD data. And what I'm aiming to show today is what else you could be doing with it. So just to see how you can gain value and support or complement or improve your work practices and use cases. So what I aim to show is a number of bits of software that Theorem can provide, and I'm hoping it will resonate with you to obviously see some of your use cases and how you may improve with them. So brief agenda. So initially, I'll show a very short video on what we're going to cover today, just to give you sort of an outline view on what's going to be covered in the different Theorem software brands. I'll give a very brief company overview because it's not all that interesting, but we'll get it covered. And then we'll move on to the three brands that we're going to cover in today's webinar. And as David mentioned, if you've got any questions, feel free to put them in the chat, and we'll pick those up at the end and cover as many as we can. So as I say, the first really is just an overview of what today is going to be. Obviously, our history and knowledge is in CAD translation. So you've generated your CAD, you've got 3D CAD. What can I do with it? So number one, obviously, you can translate it to a different CAD format or a visualization format. So that's what we'll be covering in section one, how you can utilize Theorem's software to exchange CAD data. And then really, I guess, a leap into a different form, which is how can you implement CAD data into 3D documents? So using a 3D PDF, how can you exchange a regular PDF file with your suppliers or internally, but embed it with your rich 3D CAD data? And finally, it's a look at wearable technology. So how you can take your 3D CAD, optimize it, prepare it, and use new, augmented, mixed, and virtual reality devices in your work practices, and how this can sort of bring benefit in your work practices. So to say, that's a very top level view of what I intended to show. So now, I guess, coming back to just the basics really, but who Theorem are, as David covered, we're a 30 plus year old company, and our bread and butter, our history has always been CAD translation. We were founded on CAD translation and understanding 3D CAD and, the world around that, PLM, metadata, everything that comes with that, and enabling people to share that information is why Theorem exists essentially. So we're headquartered in the UK and we've got offices in the US. Obviously, our major customers are aerospace, automotive, defence. So obviously having UK headquarters enables us to, work with defence projects here, and we've got the US team which works obviously with ITAR restrictions in the US. So yeah, sales and support offices both located in the UK and the US. And yeah, so the three brands that we're going to be looking at today from Theorem: CAD Translation, 3D PDF, and Extended Reality. So just a brief look at our install base. As I mentioned, automotive, aerospace, and defence are our main customers. Quite an illustrious customer list, as you will see there. I think, Theorem are a relatively small company, but the software that we provide, the niche that we live in, is a necessary evil for all the major manufacturers, OEMs, tier one suppliers. So you can see, obviously, some very famous automotive and aerospace names there. Defence companies, BAE, are listed there. I think some of the work we're doing with BAE at the moment is the reason that this webinar has taken place. So, those are our customers, just to give you a view on, who's using the various software solutions from Theorem. And finally, on the uncovering Theorem, obviously the partner standard bodies and associations. So where Theorem sit in the translation market is really we're independent. We're independent in the sense that we're partnered with all the major CAD vendors, which gives us access to their APIs. So we don't reverse engineer any of the translation. We read the geometry as faithfully and accurately as we can using the APIs of vendor A, and then we write it as accurately and as we can using the vendor APIs of partner B. So as you can see there, Dassault, Siemens, PTC. More recently, partnered with Microsoft on the XR project, and we'll cover that a little later on. We're members of, again, the standard bodies, which helps us drive, where the translation formats or exchange formats are going, and ensuring we know where the market is heading and what engineering companies require. And similarly, the associations, they have a sort of far-reaching view on, what's the future of technology, and where are we going. And obviously, being members with those associations gives us a view on that to ensure that we're adhering to, what industry wants and where we want to go. So, okay, I guess covering the first point then, so CAD translation. So as I mentioned, so essentially I've got an introduction slide and a video showing some software for each one. I didn't want to kill you with PowerPoint, so I always find it better to just to demonstrate the software. So as I touched on earlier, really, CADverter, so CAD Translation's our flagship brand and what we've always done. So in our development teams and our consultancy team and support team, CAD and engineering is obviously the main focus. And as I touched on, the APIs we work with in order to give you the best quality data, essentially. And what that supports, things like PMI, model-based definition, assembly structure, geometry, attributes, color information, wireframe. This by no means is an exhaustive list, but it just gives you an idea on the intentions of what we try and exchange, from system A to system B. So taking a look at CADverter then. So as I mentioned, we're CAD independent. We don't mind which CAD system you're using, and we have translators for all the major systems. For the benefit of today, I've chosen CATIA V5 to JT as an example to work with, and that's because it's a major use case we see in aerospace and automotive for using a visualization format, JT in this sense, to exchange data with suppliers and tier one suppliers and OEMs. So what we've just seen there is importing directly into the CAD system. So as I say, having access to the vendor APIs gives us access to build plugins for the various CAD systems. So what we've just imported directly into CATIA was a JT dataset. And what we can now show is exporting again. So this is some native CATIA data. We've got some capture views and PMI information shown. And again, using the inbuilt menus from within the CAD system, we can export that to a format of our choice. In this instance, happens to be JT. So we select the file, we select the location. and then, we apply that and output a file. And this is really to demonstrate, being able to repurpose your data and move it easily into a different format. We see design engineers not necessarily wanting to understand separate formats. So being able to do it in the native application is a benefit. You'll see we selected a configuration option there. Which options am I using to export? And the file has been generated. So we can now open that file in a JT viewer, and you can see that we have the same capture views that were created in the CAD system available in the output format of choice. Got the associations there with the PMI, and that information's brought through. So the next level on top of that is using Theorem's UI to do the same thing. So Theorem provide a user interface if customers require. So from there directly, we can start the translation. As you can see, that's just occurred. And there's a number of menus and features from within our UI that enable you to, determine what's happened during your translation. We can see there in the log file, CAD file successfully translated. And that is, it's all configurable and controlled from within Theorem's UI. So we have full control over the configuration that's used during translation as well. So we can see here a configuration is being created, which is essentially what flavor of options do I want to use during my translation. It may be that some users, they want, geometry, metadata, and PMI information, but others don't. So, in this instance, we're turning on the reading of PMI here. So part level PMI, reading reference geometry. So again, for a JT in particular, there's obviously the JT configuration file can be used. So this is another, external recipe file of options, and you can predetermine that. How do you want to generate your JT files? Some automotive companies have their own specification for what JTs are required and what information is required in them to be valid. So enabling us to select that is obviously a benefit. Again, mask files, so being able to define which geometry it is that you want to share with a particular supplier or partner. So if we can create a new mask file here, we can select from the entity types to translate. So we've got points, curves, skins, so skin, solid, text information. So you're basically defining what information you want to carry from your source system. And again, if your design principles use layering, so that particular layers contain the geometry, you've got reference geometry on other layers you don't need, you can predefine that in the configuration which you use. So yeah, it's just demonstrating, the plethora of options, I guess, that you can choose from during the translation. But it's really to show the principle that obviously we understand people's use cases vary, their need to exchange data varies, and having that flexibility to flick between those options is obviously a benefit that we see. And then during the translation, obviously you can select between those configuration options to translate data. So we can see a file has been translated there of that configuration type. So now this is showing the batch mode capability. So again, this is getting more towards, obviously high volume translation. So rather than doing an interactive translation, one user, wants to translate one data set, being able to build files of, translation list files to say, I've got these 100 files that have changed overnight, in my process system. I know they've changed. We need to reprocess the visualization format that supports them for data exchange. So we've shown adding a number of data sets there. And then this is adding obviously a number of JT files. So it's, it's just principally showing the building of that file using Theorem's UI. So there you can see, which files are waiting to be translated using which configuration options. You can export that to an external command file. So that is, the equivalent of a text file that you could automate. If you've got processes for exporting from PLM systems and you want to integrate with a CAD processing tool, you could build those on the fly. Alternatively, you can run the command file directly from the UI, as you can see occurring here. So that's obviously ran all those data sets. You can see there a number of green ticks saying success, but there is one showing a question mark, which is suggesting errors. And obviously from the UI, you can then come in and investigate what's happened during this processing. And we can see here a license problem listed. So that, that's a valid failure that you've attempted to do more translations than you have licenses. So the one that's attempted to run at the same time has failed. And finally, a view on the command line running. Again, this is, I guess, the most pictorial way we can demonstrate automation and inclusion of, these translation processes as part of a process or an automated scripting utility that you may or may not have in your organization at the moment. So it's really showing that, obviously, we've shown the most basic from the CAD system plugin. We've shown the next level, which is, okay, using theorems, provided UIs, doing a translation. And this is, if I was to programmatically write some software to call the translation, what can be done? And obviously running that in the command line, you can see there, you get the command files, you get the log files, you get the completion status. It's all in there. So it's just to show you the three principal ways of running data translation, essentially. And as I touched on, that demonstration showed CATIA CAD system to JT visualization system, but we've got 3D experience. We've got Composer, Creo products, SolidWorks, Creo View, NX, Creo. They're all there. Obviously, all the information for that is on our website. If you've got niche legacy CAD translation requirements, we may have a translator for it. But equally, if you're moving from CATIA V5 to 3D experience and you have a need to import NX or JT data and you're looking to for a partner in that, then obviously that's where Theorem's looking to engage with you. So that was obviously the CADverter brand, and now looking at the 3D PDF brand essentially. So I won't go through all the bullet points, but it's essentially taking the 3D geometry, so using the principles of what we've just shown with CAD translation, but rather than going from CAD to a visualization or other CAD system, going to a standalone format that can be consumed by anyone. So obviously the benefit in exchanging a PDF file is anybody can consume a PDF file using Adobe Reader capability. It's a free viewer, and a free viewer that most people have on their machine. Similarly, we see benefit in that we don't see pushback from suppliers or partners. If you imagine, you're a V5 user, you're a heavy V5 user, your partner's a Creo user, and you say, can I send you this V5 data, or can I send you JT data? They may say, I don't know what that is, step data, that's not my format, no. Whereas if you offer somebody a PDF file, inherently everyone's used to using PDF files. They know what they are. They get their bank statements in them. So people are willing to open a PDF and start to use it and see what's involved. And similarly, there's no license cost. So again, if you're working with a partner that's got a different CAD system, but you don't want to invest in the cost of a license, then this is a potential solution for you. So to begin with, I'm going to show the documents themselves, and it's most basic. I'm going to cover, what Adobe Reader provides you out of the box. So you'll see there was security there. Adding a password enables a file to be opened, and we can have read-only fields like you'd expect in a normal PDF, but you can also have write fields, so you can populate text at the point of creation that you can edit afterwards. Similarly, you can have entirely blank fields that you can populate information in. So again, this is about wrapping your 3D geometry with relevant information to your use case. Obviously, what appeared to be a 2D image is actually an illustrated view of some 3D geometry from a CAD system. So we can come in and we can change the display mode of that. Obviously, it's in illustration mode at the moment. If you select solid outline, obviously it looks something more akin to what you'd expect in your native CAD system. And similarly to the native CAD system, obviously the assembly structure is also brought through into the PDF. So you can see we've got the full tree structure of this model here, and we can select and deselect various components based on the model structure tree. So there we've hidden some bits, hidden a bolt, hidden a plate. And similarly, the attribute information. So again, if you've got rich metadata that you've put into your CAD system already, you've got material, you've got finish, relevant information you want to bring through to this document, then we can capture that and place it in these 3D PDF documents. So what I've done here is turned on the toolbar. So this is the toolbar that Adobe provide out of the box. If we provide these PDFs to you, this is the capability that you would get using Adobe Reader. So you've got pan, zoom, rotate, the normal things you'd expect to manipulate a model. We've got dimension, adding comments. So what we can do is obviously orient a model, select to add a comment, knowing that, you're going to send it to someone internally, you're going to send it to a supplier. You want someone to review, a clearance or review a particular component that you're suggesting in the design. And you can add that note directly to the model itself. And obviously you can come in, you can change that model, you can change the layout, you can change the background color. But what Adobe will do is save that view as it was viewed and created. So those views are automatically saved for you to be able to share that information on. As I've covered, you can change the display state as you've seen. And finally, this is the cross-section capability. So as I say, this is just showing you the art of the possible, really, with what tools Adobe provides you out of the box. So as I say, Adobe Reader, this functionality will be available for you all. These PDFs are available on our website if you want to access them, so you'll be able to get those as examples. So the final thing to show in this basic example is the ability to attach files to this. So it's a 2 megabyte PDF. There's 5 megabytes worth of stuff attached to it, and you can launch directly from Adobe Reader in native systems. So we've shown Excel here. Similarly, if you've got a drawing, some engineers you approach will still want a 2D drawing, but if you're looking to move towards more 3D, then being able to share 3D and 2D is obviously a good step that we see that both people are happy. So that was the most basic view. This is a more complex view on one of our templates, or I'd say probably the most complex, which is using it as a form of work instruction. So you'll see we've got the same engine data that we showed at the start. We've populated it into a 2D PDF document. We've got a bill of materials table that's been built on the fly, again, as part of the publishing process. And all of those parts are selectable. And that information is, you can predefine which information that you want to be relevant to your engineers in your use case. So this is showing, as I say, a work instruction. Step one is obviously, we want to change this alternator. It may be that you have a lot of information surrounding it that you can't include on a single sheet, but we can attach documents that we can reference and you can call from individual steps. So step 2 is obviously showing locating the alternator where it is on the engine. And again, there's no associated documents for this. Each step, you can still move the model, you can still see what's happening, but when you step back and step forward, it will be displayed in the state in which the author created. So you'll see this step is removing the pin. You'll see the bill of materials table has been updated to only show the relevant bit to that step. And again, supporting information, warning symbols if they're relevant. Again, supporting documents is, in this instance, just showing tooling required, an M8 spanner. But yeah, it's showing the principle of what you could do. So obviously, we've taken this engine from a CAD system, we've populated it into our PDF format, and then from there, we've generated these work instructions. So you'll see removing the fan. Again, get a new fan. What are the instructions for the fan? Deburr the edges, and then there's fan specs there for reference if you require it. So yeah, that's a look on its most complex, and this is just some additional examples really. So essentially, the layout of the template and the information that's included is fully configurable. We can work with Theorem to create the templates and documents that you require. Obviously, we understand your use cases, the metadata you need, the supporting information you need is going to vary. And again, the ribbon bar that's shown here, in this instance, it's shown controlling Adobe, turning PMI on and off. So again, if you've created the PMI in your source system, you want to share that with your supply chain, we can do it. So hiding components, isolating a particular component. So again, it's really showing the art of the possible, and is this relevant to you? So yeah, reset that geometry, explode the geometry. Yeah, these are just some features, and it's the use case for particular users really. Again, the capture information, which we showed during the translation step. If you've got captures in your source data, we can bring those through. This is represented as a widget, which just shows obviously moving those. And again, controlling the display state, but in a more user-friendly manner. These are some radio buttons. And finally, we've got a part list here. So again, individual part list, you can reference it. You can show relevant attributes when you select a part. So if you want to see material finish, and creator. When you select a component, you can do that. Similarly, you can search the part list for, if you've got a part number and you want to reference that, be able to find that part in the geometry you have, you can do that directly from the search capability. And again, this is just a different layout. Obviously, this is a portrait layout, the same data, similar format, but again, just showing the interactive bill of materials capability in a bit more detail. So obviously, the part number is read at the point of translation. The quantity is read at the point of translation. The other information is read from attributes. So, if you can predefine who something's, you've got designer, you've got design by, you've got the cost, it's on your data, and you want to share that in your documents, with your supply chain, with your partners, then that's achievable. It's just showing you, how you can use that. And finally, a view on, authoring them. And this is, it's basically the same as the translator that I've shown you. We can plug in. In this instance, we've got Creo. So, rather than CATIA V5, we can select generate a 3D PDF from a plugin. Your engineer can select which template they want to drive to. Do they want a work instruction? Do they want a visualization sample? Again, you see our UI. Obviously, the translator on the right-hand side is different this time, and you can build those, obviously, if you have multiple. So drag and drop. And in the same manner, you can call it from the command line. So again, if you want to embed this as part of an additional process, you want to set up a batch worker to generate these PDFs, it can be done. So again, this is just showing the command line view of that and running this time to generate the 3D PDF. So it's really just to show some continuity between CADverter and the PDF generation. And that was it from an overview of 3D PDF. So obviously we've covered data translation. We have covered 3D PDF from the Theorem software brands. And the final thing that I want to show is extended reality, which is really, sort of, it's been a focus for us for the last 5 years or so. Obviously, as the devices have become more commodity, the device price has come down, and the availability for engineering to buy some of these extended reality devices and see how they can be used to improve work processes and how they can be used on the shop floor in manufacturing is where we are and what we've been working on in the last 5 years or so. So, as an introduction, for those of you that aren't familiar with XR, I've really gone to basics of, what are these devices and what do these terms mean? So augmented reality is really to do with surfaces, tablets, mobile phones, being able to apply 3D geometry through a device and complete tasks using those devices. Mixed reality is a term that really Microsoft have used and coined, but it's essentially a holographic device you wear on your head, and you're rendering the geometry in front of you at 3D and at full scale. So being able to see a digital representation of your factory plant or your model for a design review, but using the world around you as a reference point. And the distinction, obviously, with virtual reality is VR is fully immersive. So being able to be fully immersed in this instance factory. So having a full digital representation and not using physical things as reference points. So if I just cover my one slide on what Theorem offer in this area, we essentially offer a server-based solution that's, sole focus is taking your CAD data, your engineering data, and being able to optimize it and prepare it for use in these devices. So the wheel that's shown here is really showing, again, that we're CAD agnostic. We don't really mind. You throw any CAD at it, we will prepare it and present it in a device for you. We're in a similar way, we're also device agnostic. Again, we've created some applications on devices, but we're not tied to those devices. So as new devices come on the market, then obviously we'll be prepared to make sure that, if Apple bring a new device or Facebook bring a new one along, then we can ensure you're supported and, the workflows that we've worked with you on continue to be supported as devices come on the market and retire from the market. So yeah, as I say, it's a server-based solution for optimizing your CAD data and preparing it for use in XR. So, and as we covered, those are the three devices, you know, the three, well, not device types, if you like, so where we can optimize and prepare data for. And Theorem have a number of our applications, so we coin them experiences. So visualization, design review, factory layout, visual digital twin, and training. We offer those solutions. Similarly, we work with our supply chain. So some people we work with have developed their own applications. You know, they've got their own virtual reality application they've developed for specific training to do with their specific use case, but they struggle with the preparation and optimization of data for usage in that area. So in that instance, we just offer the pipeline solution to say, okay, give us your CAD, throw your CAD data at us, we'll prepare it and give you an output format of your choice, which you can consume into your application. So again, we don't mind if you've done your own investigation, you've done your own development into XR applications. We can support that, or we can support you with an end-to-end use case. And I've got a final video really just to try and demonstrate some of the applications and use cases here, and hopefully they'll resonate with you. You know, you could see where they may be able to be used in your workflows and processes. So a view here is that playing? Give me 1 second. No, there we go. There we go. So yes, so we can see another data set here. Again, it's just an example JT file. On the right-hand side, we've got a web browser view on the pipeline server. So again, this is the interactive use of the pipeline to optimize and prepare data. So what I'm showing here is obviously a user view. But again, what we can do is, we've got obviously APIs, we've got plugins. You know, it's a web services based call. So if you've got a need to plug this in as part of a process to extract data and optimize and prepare it for XR, then we can automate that process. So we can see here, again, it's the usage of configurations to say, okay, how am I going to prepare this data for use in device? And I guess for those of you that don't know, obviously, mixed reality devices, it may be that the local processing on the device may struggle more than virtual reality devices that use heavy PC-based machines to drive them, obviously with graphics cards and renderers. So sometimes there's various manipulation that needs to be done to ensure the geometry that's presented is light enough to work with. So obviously that's one of the benefits and use cases for Theorem XR. It's using the pipeline to optimize it for your particular use case. So we can see that data has been optimized and prepared. And we can see here that that's now available for use on the, in this instance, HoloLens 2 device. So that same data that was a JT file is now available as a rendered hologram for you to interact with. So obviously this is showing visualization, bringing this model in and being able to visualize it in this space. We have some customers that do this with plant machinery. They can bring it into their space, locate where it may go in a new factory design, for example, this particular use case. And again, this is just showing the information that's in your CAD system is there and relevant. So again, it's just showing the application of materials. You can see there that it's been snapped to a QR code. So again, moving on now, this is showing obviously the same application, but working collaboratively. So we've got one user in the same location using a HoloLens 2 and a third user using a VR headset. So again, being able to mix those devices, but be able to do the same thing is one of the benefits of obviously using Theorem's device agnostic approach. So we can see here users in the design review measuring, adding comments, recording images, being able to digitally review a design and make decisions, collaboratively using, there's voice control. You can talk to each other through the devices and make decisions in an environment. Finally, this is showing a factory layout application. So again, this is being able to load multiple models into a scene and place them and locate them relevant to your space to make decisions on your design. You know, it may be your plant design, a new plant that hasn't been built yet. You could take a device on site and visualize, you know, workstation areas, work areas, and make decisions at full scale. You know, the benefit of XR is really cognitive use. You know, that's how it's coined. It's being able to experience a design at full scale. You know, seeing something on a screen in CAD isn't necessarily the same as being able to say, you know, this submarine I've designed is vast. Can I get a sense of the scale using these tools and how best they can help you make design decisions? You know, we're showing here grouping, copying and pasting. They're just features to demonstrate, obviously, the interrogation and usage of large data sets. So I mentioned earlier, obviously, that there can be some restrictions on devices, but there are ways to alleviate that. So what I'm showing here is using remote rendering to render down to the device. So again, this is showing a full factory. So a full-scale factory implementation, you know, a full design, but rendered down from the cloud to a HoloLens device. So this is obviously leveraging our partnership with Microsoft, is being able to use their Azure remote rendering capability and at full scale and full fidelity, you know, stream huge volumes of data down to a device. So again, it's to enable you to get all the information you need down to a device and make decisions based on the geometry that you have available. So this is now leaping over to VR, and it's showing the same principle, really. This is showing the factory layout application. As I say, you know, it may be that you have this facility designed in Navisworks or Revit. You've got your models designed in some legacy system. You've got scans of some existing, you know, tools and machinery that you didn't get the CAD system for. And this is about, you know, being able to bring all of those things together and be able to make decisions on your design based on, you know, based on being able to visualize it and use it in these new devices. So we're showing here, obviously, ergonomics, being able to bring mannequins in, position them, and make decisions in work areas using, you know, 95th percentile mannequins. Again, this is showing what we showed in the HoloLens. And this is showing, again, another collaboration session, but again, using VR in this instance. We've got 5 users in this session. So you can see we've got desktop users, we've got VR users, and we've got a HoloLens user. They're all looking at the same thing. We're, you know, working collaboratively in this particular sense to say, okay, we've put the new robot cell design in here. It doesn't fit with the new rollers that are in there. Okay, how does the robot interact with it? You know, what replaying animation or, you know, stuff that you've created in robotic systems, being able to bring that into this environment and replay, you know, those moving is obviously of a benefit. And obviously dimensioning, again, being able to take dimensions on particular proposed designs and determining, are they, you know, is that good enough? Is this area good enough to work in? So this is just reviewing the comments at the end of the session, showing that you can record that. You can keep those design review sessions stored on your server. And if you want to load those up again at the point of creation, you can. So again, moving on to our guides capability. So again, this is a VR-based capability, but this is to do with training. So what we're showing here is authoring essentially a work instruction for someone. So authoring the work instruction and saying, you know, these are the particular tasks that we need to create, and being able to then replay that and train someone in doing the task required. So what we're showing here is obviously removing the motherboard and removing some brackets. But this is another one of Theorem's experiences. So being able to use VR as, you know, for training and work instructions is the principle behind this one. Obviously using tools if tools are required and actions are required. And this is showing the operator view. So obviously we showed the author view. What we're now seeing is, okay, so a user's come in here. Their next task is screwing these screws in. They hit next, you know, I've completed that task. Okay, what have I got to do next? Okay, go over here, get the hard drive. And it's about training people. And obviously the use case for this could be, you know, you've got people in environments that you can't necessarily train them in, or it's expensive to train them in certain machinery. So if you could do 70% of the training digitally first, you're going to see a massive cost saving. Obviously working collaboratively, no travel COVID restrictions, all those things are, the benefits in XR. These are the things that we're seeing. And finally, this is just, again, a view on the tablet. So just to round up, really showing Theorem AR and using the tablet to, in this instance, apply a digital representation of a new robot layout and determining dimensioning against that environment. Will this fit, and is this proposed design going to fit? And that's it, really. Again, as a potted overview of Theorem XR, and I think that sort of summarizes everything I want to show. I think obviously time-wise we've hit the 40 minutes, so that's good from me. But as I say, what we've really shown today is sort of some software, the features of the software and how it could be used. But what we're most interested in really is obviously talking with you guys on seeing that and working with you to determine, what are the best use cases for you, using these various softwares. Is there a benefit? Can you see particular work practices that aren't functioning very well, and it's costing a lot to implement changes, or to fix things that could have been addressed earlier if data was exchanged correctly, or if reviews had been done in a more wholesome, full scale way. What are those benefits? And feel free to contact me. Obviously, my contact details are there directly. If you've got a use case that you think actually this this XR technology or this PDF, or that I have a data exchange need. If you want to approach me directly, then my information's there. Otherwise, I'm happy to receive any questions, anything that's come in during this.
Okay, thanks very much for that interesting talk. So I've got a few questions coming. So the first one is, what's the main benefits of using the translation tools over directly exporting from a CAD tool?
Well, I guess the benefits that we see, I think, with data translation is obviously being able to replicate. For example, if you were going V5 to NX, if you were going to use an inbuilt CAD tool, you may end up using a step file or another standard format. And again, more often than not, those are licensed in CAD systems, so there'd be additional cost anyway. And you may lose some of the intelligence and functionality in the 3D CAD, which you've already put in. You've already got in there, and obviously those the standard formats, the support for them is obviously limited. So what we aim to do is obviously use the native APIs to read and write, so we can faithfully create the NX geometry as accurately as we can. Because obviously, if you were using CATIA's step exporter, for example, and then you were using NX's step importer, you don't know who would be to blame. You're using a standard format that might not necessarily carry as much information. So you're limited in what you can do. What we aim to do is obviously keep the data as rich as we can, keep as much of the information as we can. And obviously, we've got a full support team here, a development team, to work with people to get, as new CAD availability comes out, new support for composites or whatever it may be, we can quickly turn around support to enable to ensure you getting the best from what you've done.
Okay, thanks. So the next question is, if you were using a 3D PDF document and it had some CAD data in it, could you then use that to extract that data into a CAD system?
Sorry, can you say that again? Sorry.
So say you've created a 3D PDF and you sent it to somebody. Could they then take that 3D PDF and extract the CAD data out of it and use the CAD data?
No. So essentially, the 3D PDF format is a standalone document format. So the intention's not to use it for exchange. It's not like a JT or a step. It's essentially a sharing, document, standalone document you can share. It's not something you can then extract that 3D data from.
Okay.
And I think it's probably worth noting as well, obviously, theoretically, we can translate, a whole plane into a 3D PDF document. But again, the viewing capability provided by Adobe might not necessarily support it. So, PDF is a portable document format. That's its intention and that's its use. So knowing that, knowing the data exchange, the data you want to exchange and what can be exchanged is also, beneficial.
Okay, moving on to the XR stuff. Is it possible to use augmented reality to kind of overlay the CAD on the actual product and then show a maintainer how to do something?
Yes. So we haven't shown that in the slides today, but yeah, we offer a CAD overlay capability. We coin it, and that's essentially you use physical geometry as a target marker. So you can either use the model you're looking for or an alternate model. So, for example, if we use what we've demoed today, the alternator in that sense, you could say, actually overlay the real life alternator or a variant of that alternator on what we've got at the moment and use that as the target. Similarly, you could say, okay, I've got the alternator here. I want to overlay the engine in context of where that alternator is currently in my session. So, you can say, look for the alternator, but give me the surrounding geometry and the alternator. So yeah, that's feasible.
Okay. What's all the questions we have?
I think I've seen there's some come in. There's a few others come in that I don't know. I can see in the attendees question. There's a couple come in while we were talking there. I don't know if you've seen those.
They're not on my screen.
Oh, okay. Well, I can run through them. I can see them. So the first question asks how the solution's different from 3D Experience. I'm not entirely sure what that's asking. Obviously, we sell translators. We work with Dassault. We embed in 3D Experience the ability to export data from Anovia to alternate formats. So if you want to go 3D Experience to JT, for example, or 3D Experience to NX, we sell translators for that. Similarly, we've got 3D XML, processing in our XR capability. So as I say, I'm happy to catch up on that question, but I'm not entirely sure what it's asking in reference to comparing it with 3D Experience. I think, the second question you've asked, we've covered the 3D PDF for exchanging between platforms. So there's a question about PVZ, and we do support PVZ. The animations is an interesting one. The animation one we've had raised a number of times. So the question, sorry, for everyone's benefit, is do we have PVZ that supports animation through to FBX? And we have worked in that capability. Unfortunately, there's no API that supported by PTC at the moment that ensures that what we do is consistent going forward. So I think there's limitations around that area, but again, I'd be happy to discuss that and that particular use case as required. So there's a couple more questions I can run through if you can't see them, Manuel.
No, sorry.
No, it's no problem. I'll carry to run through. That's not a problem. So it's asking around, what it would take man hours to generate the work instruction that was demonstrated there. Obviously, so the way that one was being created is essentially we populate the 3D data into a file, and then in Adobe we provide the user the capability to then pull parts, move parts, hide parts, orient the model, show what's relevant. So obviously it would take some getting used to that process. It may take, an hour or two once you're used to that. You load your data in, you work through the steps, obviously typing all the steps in, associating which geometry is relevant to which step is all obviously done directly in the PDF itself. So it would take as long as however many steps it is that you need to create, whether that be short or long. So it's relevant. So the robot factory floor. So So again, the question again for everyone's benefit is with the operators and the robot and the workstation. So that in XR is a much quicker task, really. Obviously, you need all the models available to the user directly from the TVP server, and then they can draw them down and just place them in space. So as you load the model, you can place it where you want and build that environment. Similarly, we offer a desktop application. So again, if people wanted to pull those factory layouts together in a desktop application first, then put on a HoloLens or VR kit, and then tweak them. So, we work with customers as well on integrating it with their current system. So we've got one customer using 2D schematics of their layouts. They define it in 2D schematics. They link it using an attribute to say, this part goes here, this part goes here. We then consume that, via an XML form. We generate the layout that they've created in 2D using the 3D assets we have available. They can then load that layout, move it around, and export that back to an XML form that can be consumed by their existing system to say, actually, on looking at this in 3D, I've made these decisions. So, yeah, there's plenty we can do around that. And, what I tried to give today is an overview of everything, knowing that, there's potential for, individual use cases is where we see the most benefit. Working with you and obviously understanding what features we've got that are applicable to your use cases helps drive this. We've got a question around AR hardware. How much does AR hardware cost? It's a valid question. Obviously, AR, you could be looking at mobile phones or tablets. So if you've got those on the shop floor at the moment, extending the use of them is obviously one of the major benefits we see. Obviously, the cost of those is a couple of £100, dollars, whatever it is that you're using. The Microsoft HoloLens device, I believe, is £3,000 currently. So that's obviously the holographic version, the head-mounted holographic version. But the benefits that you get, in cost reduction for using that, to do various tasks is obviously, again, return on investment is principles we work with on our customers to determine, you need a use case that's going to show value. You need a use case that obviously XR is supportive of, but also shows value on top of it is what you're doing. So this final question, XR collaboration, are the sessions hosted on a cloud solution or from one of the user's device? So the server that I showed is obviously, that's essentially the brain of Theorem XR and our application. So that manages the collaboration sessions. So if a user can access a Theorem XR server and they're invited to a collaboration session, then they can join it. So we've got customers that host it on premise. So obviously some customers don't wish to make their CAD and engineering data available on XR externally. So they don't want, the service on the cloud. But they obviously can work collaboratively internally on their system. So yeah, they can work, if you've got a particular site or they're all on the same network, then you can access an XR session. Similarly, we host cloud-based services for people. We've got VMs running Theorem XR, and that obviously opens essentially an external facing IP address on the internet to say, can I join a session? Somebody's they've got the IP address of the server. They can access it from a device. They can join a collaboration session. So both are achievable. Either collaboration locally, at the same site, hosted from a laptop, theoretically, whether it be in a data center, splitting the database and applications and all of your storage, or whether it be a cloud-based solution. The intention behind Theorem visualization pipeline, the server solution, is that it's scalable. So obviously we work with customers in an R&D sense, having local instances that people can connect to, and we have customers that have, as I say, got full data center implementations linked with their PLM systems and various other things. So the options are there. And I think one final question on, I had to transfer a file from Navisworks to Autodesk as an assembly. So it's essentially a Navisworks to Inventor translator. That's the request. Unfortunately, we don't sell such a product, so we don't have that capability available at the moment. And it's not one that I've had requested before. That's not to say we can't support it. So again, if that is a requirement, I guess we could catch up offline on this, and we'll determine if there's anything we can support you with on that. And I think that's it. Actually, I think one more question may have just arrived. Yeah, so again, someone's asked a question, do you have information about which hardware has the best performance with AR? I'm currently working on HoloLens 2 with more complex models. HoloLens 2 have a lot of lagging. So again, I touched on that during the presentation, essentially. We work, the pipeline's main function is to optimize and prepare data for usage on the devices. So if there's limitations of the device, as you say, your current models are lagging in HoloLens 2, there's a lot we can do with collapsing the structure, obviously reteslating the meshes, grouping nodes. The whole purpose of the visualization pipeline is to ensure that the geometry you're getting to the device is going to work successfully for you. And that's the key aim, and that's the key aim for us. So obviously there are limitations to the device, and if you're looking at pushing a 2 million polygon huge model data set to the device, it will lag. So obviously there's things you can do to optimize it to get that down. Alternatively, you've got what I demoed, which is the remote rendering capability. So again, if that's of interest to you, that's essentially we've got a 300 million polygon factory that we can stream down to the device. As long as you've got a good internet connection, you can use the HoloLens 2 with rich data sets, full fidelity, no optimization required. So if that is of interest to you, again, we can be in touch to give you some information on that. And sorry to take your job, Manuel. I've sort of read and answered my own questions there, which is, yeah, sorry you couldn't see those. But that's it from the questions that I can see on that list. So I think, as I say, anything else that people want to raise after this, my details are on the screen there. Feel free to reach out to me. And thank you for your time.
Well, thank you for your time as well. Thank you very much for your very interesting presentation. You've covered quite a lot of use cases for the software. So on behalf of the IMechE, I'd like to say thanks very much.
Thank you all.